Today, we have already finished covering the life science part for the lower block. So today we're looking at covering the physical science part for the lower block. All right, so the topics that we're looking at for this particular lesson will be diversity of materials, cycles in matter, magnetic forces, and energy forms and uses. All right, so let's see, what do we need to know for diversity of materials? You should be able to remember how different types of materials are used based on their physical properties. Like, why is ceramic used for certain certain purposes? Why is fabric good? So very common questions would be like, I've got a helmet. Part A of the helmet, which material should I use? The visor of the helmet, which part should I use? What material should I use? Or if I've got a raincoat, what type of material should I use for raincoat? And then explain why you choose those materials. Like, can I use a fabric? Why or why not? Because it absorbs water, it doesn't keep you dry, it's not waterproof. So these are certain keywords that should come to your mind when we're talking about materials. Okay, we're also going to compare the physical properties of materials based on strength, flexibility, its waterproof ability, transparency, that means its ability for light to pass through, its ability to float or sink in water, and its magnetic properties. Whether they are good conductors or poor conductors of heat, or whether they're good conductors or non-conductors of electricity. Even though these 2 points are properties that are learned in primary 4 and primary 5, they are still included under the physical properties of materials, and you can use concepts from there to actually explain why you choose certain materials over others. Okay, take note, you may have used the words elasticity or hardness before, or even the terms durability. You do not need to know about elasticity or hardness. Hardness means ability to scratch or to be stretched, or to scratch another material, right? Elasticity is to be able to stretch and recoil back to its original position. And durable, take note, is not accepted as a reason for choosing a material because it is too vague a term and it is not considered a physical property. So like, why is something durable? Do we say maybe it's non-biodegradable, for example, so it's durable? It doesn't break easily because it's elastic, something like that, okay? But we don't use the term durable or lasting. Okay, so let's take a look at our very first question. Okay, so which answer do you use for why this measuring tape is suitable for measuring curved lengths? All right, so there's certain important keywords that you may want to underline as you're doing the question, right? So I want it to be curved lengths, not just straight lengths, which is why I use a measuring tape, not a ruler, right? Okay, next one. James has a pot of water with a layer of oil as shown. Okay, so based on your observation, what did your give as a physical property of oil? Is it elastic? Is it hard? Is it cute? Okay, so what was the physical property that you actually wrote based on this particular observation? Okay, oil has no definite shape. Okay, interesting. Buoyancy. Oil has the ability to float. Okay. Ability to float on water. Very good. So that becomes a more specific answer, because if it's just can float on what? Oil floats on water, or oil can float on water. So if you just say oil floats, it is not specific enough. Oil floats on what? Okay, so you do actually need to specify that it's on water, because if I were to mix oil with alcohol, for example, then oil may or may not float. Okay, so we have got to be very specific based on this specific observation. Here, Caden actually says oil has no definite shape. Okay, can we accept this possible observation of oil has no definite shape? Based on this particular observation, I can't tell whether oil has a definite shape. And if oil has no definite shape, then I should be able to see in 3 different containers of 3 different shapes, for example, right? So based on this, the best answer would be its ability to float on water, and it's not good to write oil is lighter than water, but we say that for the same mass of oil, it floats on water, then yes, possibly. Okay, so other possible answers that you may know or you may not know that we could accept would be oil is less dense than water, because oil is less dense, hence it can float on water. Or you can say that oil does not mix with water. Or the last one you can actually state is that oil does not dissolve in water. So there must be some kind of interaction with water in your answer. Okay, a comparison to water based on this particular experiment. Okay, so good job. Next one, let's look at cycles. Oops. Okay, so for this topic, you should be able to state that matter, by definition, go back to the definition of matter. What is matter? Anything that has mass and occupies space. And you should be able to differentiate between the states of matter. Just now, Kaden talked about oil having no definite shape. So yes, that is already considered a property of liquids, right? When oil is in the liquid state. So the differentiate between the states of matter in terms of their shape and their volume. Is it fixed? Is it not fixed? Is it compressible or is it not compressible? So these are important keywords that you should be able to surface correctly under the correct relevant experiments. And you should also be able to measure mass. Okay, but take note, you don't need to physically measure. That means I won't give you test tubes in a PSLE and then see whether you can measure all this stuff, right? But you should be able to state what apparatus I can use and what are some of the readings that I should expect. Is this particular apparatus for measuring mass, or is it for measuring volume? Trap stump gas. So this is gas. All right. In an airtight container, he then put this piston upwards. So what happens to the mass and the volume? Okay, so let's go back to the definition of mass. Mass is the amount of substance, right? Amount of substance. And what is volume? Volume, by definition, is the amount of space that a particular substance occupies. Okay, so if we can remember these definitions, then let's see. Even though I pull the piston upwards, does my mass change? The amount of gas W remains the same. So if I do an actual physical count, 3, 5 plus 5, there are 10 particles of gas W on my left-hand side before the experiment. And then when I pulled up the piston, I still had 10 particles of gas W. So my mass actually remained the same. So it's either B or D then. But let's look at the volume. Volume, by definition, is the amount of space occupied. I realized that originally gas W occupied this amount of space. So it is length times breadth times height. And here, this is the amount of space that gas W now occupies. Length times breadth times height. So do you realize that by length times breadth times height, the amount of space the gas occupies now actually increased? So therefore, like that and like that, the only answer is therefore B. Okay? So you must go back to the definitions of what mass is and what volume is. Okay, you may want to jot this down in your question so that you can remember these definitions, because if you don't know these definitions well enough, you're going to get confused when we attempt similar questions. Now, let's look at the next question. Sail back on stringers. So they like to deal with stringers a lot because it tests on your understanding of properties of liquids, gases, and solids. So Sidrel fixed a stringe, and this is the volume of air. Okay, because this is the volume of air in the stringe that we're comparing over time. So when I don't add any weight, the volume of air is 50. When I add one weight, it decreases to 46. So this will probably cause the stringe to be compressed a little bit. So when the piston of the stringe moves down, the volume decreases in the stringe by a little bit. When I add two weights, two 20-gram weights, volume of air decreases again. When I add 3 weights and 4 weights, it becomes 40 and remains at 40. So based on this, the question is, how did the volume of air in the syringe change with the number of weights? So I see that, okay, so I have to break it up. There are 2 parts to this question, right? I must describe both trends. I realized that when I added weight, I added up to 2 pieces of weight, the volume of air will decrease. But if I add 3 weights and 4 weights beyond the third weight, the volume of air actually remains constant. There is no increase or decrease. So in your answer, I want you to check, did you describe 2 trends, or do you just state, oh, as the number of weights increase, the volume of air in the syringe decreases? Because that would not be a fair representation across all the number of weights. So a good answer would therefore describe, as the number of weights increase from 0 to 2, the volume of air will decrease up to the third weight. Or rather, yeah, from 0 to 3, right? But beyond the third weight, the volume of air will remain the same. So make sure in your answers, if you are doing your corrections, that you make a note to yourself that if there's an increasing, decreasing, an increasing remain constant, or a decreasing remain constant, you must be able to state the 2 different trends. Okay, we don't need to use only one sentence to describe. No problem, Sarah. We don't need to use one sentence to describe one trend. In one question, there could be 2 trends or 3 trends. And if there are 2 to 3 trends, you can use one sentence to describe each trend. So in this question, there are 2 sentences, then you can get your 1 mark. Okay, next, predict the volume of air when 5 weights are placed. I'm sure most of you are able to tell me that it will just remain at 40 cm cube because the air in the syringe cannot be compressed further. So the keyword that I'm looking out for is compression. When you get to secondary school, you recognize that all these particles of air, they actually will come closer together when they are compressed in a syringe. So when they're compressed to the point where there's no more space between them, then they cannot be compressed further. So take note, you must state where. Don't just state air, because there's air outside the syringe and there's also air inside the syringe. So you must state that it's the air inside the syringe that cannot be compressed further, because air outside the syringe is still compressible. Okay, so next topic we're looking at will be interactions, specifically between magnets. So when it comes to this topic, you must remember all your properties of magnets. So magnet or magnetic force is basically either a push or a pull. So when it's a push, we use the word repel. If it's a pull, we use the word attract. Okay, so it's therefore a force, because by definition, a force is either a push or a pull. Then you should be able to state the different characteristics of magnets. They are usually either made from iron or steel. They have 2 poles, north and south. A freely suspended magnet will rest in the north-south direction. So this freely suspended magnet can either be on top of or on the surface of water, or it can be hung freely from a string, right? So these are 2 ways that magnets can be naturally suspended. That unlike poles will attract, and that like poles of a magnet would repel each other, and that magnets would attract magnetic materials. And you all will need to remember what your your magnetic materials are. SINC, right? I'm assuming you remember what S is for. So there's SINC, right? S is for. Okay, maybe very quickly, you'll just type inside the chat box, what does SINC stand for? The most commonly tested ones will be S and I. N and C, not so much, which is why sometimes people get confused between the C. Good. Iron, cobalt, steel, nickel. Very good. Okay, there are some people that think that C stands for copper, so that's the one that people get confused with. So take note, C refers to cobalt, not copper. Right, very good, Gwen. SINC, all done nicely. Okay, so you also will need to compare between the properties of your magnets, your magnetic materials, and the non-magnetic materials. So like, what is the difference between a magnet and a magnetic material? A magnet with another magnet can repel, for example. But 2 magnetic materials, you push them together, they can't attract each other, they can't repel each other. Okay? And this one, describe the stroking and electrical methods to make magnets. So the electrical magnet will give you an an electromagnet, for example, and to state the uses of magnets in everyday life. Okay, so let's look at this question. Okay, so let's look at the stroking method. Okay, I'm going to give you a clue. When it comes to the stroking method, the part where, okay, so if this is north, the part where north, yeah, you all can change the answer, but you all know that more important is the reasoning, right? So if this is north, when the north first hits the magnet, this part will also be north. And the part where the magnet lifts off will be opposite to the magnet's original pole. So if this was north, it left off at C, it lifted off C, so C should be south. Okay, so you need to remember this point. The point where the magnet first comes into contact with the bar should be of the same polarity. Then where the magnet leaves the bar, it should be of opposite polarity. Okay, do you want to write this down into your notes so that you can remember? Where the bar first contacts the magnet, they will be of the same polarity. Where the magnet lifts off the bar, they will be of opposite polarity. So the stroking method is one that is very commonly tested. So you must remember what I just mentioned. Where the magnet first contacts the bar, same polarity. Where the magnet lifts off the bar, opposite polarity. So therefore, I will be able to recognize that C and D will be south and north respectively, which is here or here. Then, if we could get this part, so S first strikes this bar at here, and it lifts off E at here. So therefore, opposite polarity. Likewise, north started here, so therefore here must be south, and here must be north, then it left off at there, at south. So therefore, E will be north, and F will be south. Okay, so that's the important concept for this one simple question, which is why the answer is C, not B. So the fact that most of you all chose B means you all had the opposite notion of what's actually going on, because your answers will be exactly opposite to the correct answer. Okay, but no worries, at least we sorted out this time, so that's a good thing. Next one. Okay, so we have looked at the stroking method of inducing magnetism. Now let's look at the electrical method of inducing magnetism. So in this particular question, Ian wanted to investigate how the number of batteries, so this is my variable, affected the number of pins attracted. So he placed the bar 1 cm from the pin and recorded the number of pins attracted when he increased the number of batteries from 3 to 4. And he realized, 一样的, still 6. Right? So, first question, name one material that would be suitable to make this bar. So we know for sure, I am sure that you all will be very good at this, you have to state a magnetic material, and the most common magnetic material would be steel or iron. Very good. Now, suggest 2 reasons. So if it's a suggest, sometimes we have to use our common sense. So 1 mark for each suggestion. Why the number of pins attracted did not increase when the number of batteries increased from 3 to 4. Okay, let's discuss some of our friends' answers. And we see which of these we agree with, then we can just jot this down as additional reasons for ourselves as well. So Hannah says that the battery that he added was not in working condition. So if either the battery is flat, totally depleted already, then it would not increase the electromagnetic strength, which sounds possible because we know that for to increase the strength of an electromagnet, we either, number 1, increase the number of batteries, or number 2, we increase the number of coils around the bar, right? So in this case, we know that the only thing that he did was increase the number of batteries. So therefore, based on this experiment, we do not assume that he unraveled or unrolled additional coils from the bar. Okay? So yeah, if that's the case, potentially. So Hannah's answer sounds possible. Colette says the number of coils wrapped around the bar were not enough. But if the number of coils wrapped around the bar were not enough, then even at 3, there should not be any, in fact, if the bars were not, the number of coils were not enough, there will be not enough magnetic strength at all to attract any number of pins. So Colette's reasoning may or may not actually make sense in this case. Okay, Gwen says a magnet's magnetism acts at a distance, and 1 cm is the nearest distance for the electromagnetized bar to act on the pins. So if I were to move the bar closer, instead of having this to be 1 cm, I change this to be 0.5 cm, will it still attract? If I decrease it to 0 cm and they're directly touching the number of pins, touching the pins, would my electromagnet still attract? It still would, right? So I won't say that 1 cm is the nearest. If there's 0 cm, there will still be electromagnetism. Okay? Ollie says he added another, yeah, so that's the one where I said, yeah, in this case, we know that there was additional batteries, but we don't decrease the number of coils. Kaden said he added more number of coils, but decreased the number of batteries. But in the question, we know that he only increased the number of batteries. He didn't do anything to the number of coils. Nathan says 4th battery placed in had no energy. So yeah, potentially means it has either been depleted or is damaged. The rest of the pins were not made of a magnetic material. Yes, that sounds possible as well. That's interesting, right? So based on what our friends have said, we can find 2 reasons at least why the number of pins attracted did not increase. So these are a few possible answers. The increase in magnetic strength was not enough to attract another pin. So with the additional battery, there would have been an increase in magnetic strength, but that magnetic strength is not strong enough to attract another pin. Maybe you need 2 batteries to attract 1 pin, for example. Okay, or that the electromagnet had already reached its maximum strength. So no matter, even if I add more batteries, even if I add more electric coils or more coils around the bar, it may not give me additional magnetic strength. 4th battery was flat, depleted, or you can say no energy. The other one that sounds very possible. There was not enough space on the bar. Here, even if they could attract, maybe I could have a pin that's attracted to other pins. If let's say the magnetic strength did increase. Okay, but if that's the case, it would have still attracted the number of pins, cause the number of pins to increase. Okay, so these are some possible answers. Yep, when electromagnetized bar had already been fully coiled at its greatest maximum strength, so correct. So what Hannah is saying that the rest of the pins were not made of a magnetic material, it sounds possible, but usually in any experiment, to ensure fairness, we will make sure that all the pins are of the same material. So one of the ways that we can think is to imagine ourselves carrying out this experiment. So if you imagine yourself carrying out this experiment, it might be easier for you to identify what the problem is. Okay, so I like to put myself into the shoes of the real scientist doing it, or the student doing it. Okay? Yeah, battery spoiler. Okay, now let's look at the next topic on light. So for this, we need to recognize that an object can only be seen when it reflects light or it itself emits light. And shadows are formed when there is partial or complete blockage of that light. Okay, and we're also going to look at the variables that affect how shadows are formed in terms of the shape, the size, and the position of objects, and the distance between the light source and the object, or the object versus the screen. So this was the question that was asked. Okay, the concept to recall is that the closer you are to the light source, the larger the shadow. So this has the largest shadow. So I would therefore assume that this middle person must be the one that's closest to the light source. And if it's the smallest shadow, which is here, it should be furthest away from the light source. So if that's the case, the middle one must be closest to the light source. Look at A, B, C, D. Who's closest to the light source? So it's either A or C. And then I want this person to be furthest away. So furthest away cannot be A already because this is not the furthest. Instead, it's this one. Right? So the correct answer in this case is C. Okay? Because the smallest person is furthest away, the largest person is closest. Then this will give us closest. furthest. So C would be the correct answer. Okay, so that's the concept that you need to recall. So you play in the exams, you play with your pen, then you check. Okay. Next one, this is also a very common question. They use data logger and then they start passing things through a light sensor. So if a ball passes through the light sensor, passes through the hole, there will be a gap. So you have to assume that this light source and the light source is emitting light and the light sensor is detecting light. So when there is a gap like that, it means that the light source, or rather the light detector, could not detect any light from the light source. So at these gaps, this is where something was passing through to block the light source from sending light to the light sensor. Okay. So balls were thrown one at a time and the graph shows the results for the first 20 seconds. Now explain how this setup was able to count the number of balls. So for 2 marks, let's see. It's very close to what I was explaining, essentially, right? So we need to be able to state, number one, that light can be blocked and that the light sensor by right detects light from the light source when there is no blocking of light. Okay, so when a ball is passed through the hole, it blocks light from the light source or it prevents light from the light source from reaching the sensor. So at these points, there will be 0 light detected by the light sensor. So the number of balls that passed, because I want to see, count the number of balls. So the number of balls that passed would be the number of times the sensor did not detect light from the sensor. Okay, so you need to explain in 2 sentences. So for those who have been with me for a while, you know that I always emphasize on having short sentences, but you can have multiple short sentences. So to get these 2 marks, you don't need to write one essay with 1 full stop. You can have multiple sentences, multiple full stops, so that each sentence is short and sweet with the important keywords. Because long convoluted sentences means you're also grappling with the grammar of the sentence. And if your grammar can sometimes cause you to lose science marks because you can change the meaning of the sentence if it's too convoluted. So short sentences are good. Okay? So how many balls pass through the hole in the first 20 seconds? So we just need to count the number of times that the light source was blocked, or rather we count the number of times where the light sensor detected 0 light. So if you look down here, 0 light, 0 light, 0 light, 0 light. So that means how many balls will pass through? Probably 4. And that gives you the marks. Just state correctly. Okay? So in the first 20 seconds, did all the balls pass through the hole at the same speed? And then explain your answer. If I look at the interval, this interval is short, this interval is short, this interval is long, and then this interval is short again. So the longer the interval, probably the faster or slower. Very good. So the longer the interval, the slower the ball must have passed through because it blocked light for a longer period of time. So based on that, the bottom parts of the graph already represent. So my answer would be no. Light from the light source was blocked for different lengths of time. Then you make the connection. The longer the light was blocked, or the longer the time interval, the slower the ball moved. So it is better to state the relationship instead of saying, oh, the first ball and the second ball pass through at the same speed. The first ball, second ball, and fourth ball pass at around the same speed. But the third ball, okay, interesting. How about the size of the ball? Could it possibly be that the size of the ball was different? Yes, it could be. So let's look at the question. Did the question actually tell me what type of balls? They didn't tell me the type of balls, so I may be able to assume that the balls could be of different size. Or I could also make the assumption that the balls were moving at different speeds. So yes, I can say that the size of the ball was different. So this question can be modified to make it into the size of the ball was different. Assuming that all the balls are moving at the same speed, then if the interval is different, assuming that the balls are all moving at the same speed, then the intervals, if it's different, will tell me that the size of the ball is different. So this was likely going to be a larger ball. But in this case, because the question did not actually tell me whether the balls were the same size, not the same size, I will make the assumption that the balls are the same size, but they're moving at different speeds because the question gives me a clue that they're probably passing through at different speeds. Okay, but yes, Ollie, that's a good connection that you can make. That's another possible inference or conclusion that I can reach based on this graph. Okay, so that's a good one. Next one, let's look at energy. This time we're looking at heat energy. So you should be able to state the common sources of heat, fire, sun, that kind of stuff, and state that temperature, okay, this is the definition, is the measurement of the degree of hotness of an object. Okay, so you need to differentiate between heat and temperature. You also need to show understanding that heat always flows from a hotter place to a colder place, or from a hotter object to a cooler object, until both of them reach the same temperature, and relate and temperature changes to heat gain or heat loss. So if we know that heat always flows from a hotter to colder place, we know that heat, when an object gains heat, it will expand. When an object loses heat, it will contract. We don't say they shrink. Okay, so it's expansion and contraction. And then we should also be able to identify good and poor conductors of heat and their uses. So like, what are the parts that are used to make a cooking pan? The handle, the pan surface. So all these will be based on your knowledge of whether they are good and bad conductors of heat. Put in place a ceramic plate. So basically, when she removed both at the same time, the next day, one in each hand, this plate, felt colder than the bowl. So the science behind this is that whenever we touch something cold, heat will flow from our fingertips to the cold object. So when I touch a piece of ice, it's not because the coldness from the ice transferred to my hand, but it's because heat from my hand left my fingertip and got transferred to the ice. So the absence of heat on my fingertip makes it feel cold. Remember, coldness does not travel. Heat travels. That's why aircon doesn't travel, but heat will travel. All right. So this is the main explanation. If both of them were left overnight, then I'll have to assume that they must have reached the same temperature that's set in the fridge, which for most of our fridges is between 2 degrees Celsius to 6 degrees Celsius. Okay, so assuming that both are 2 degrees Celsius, and I know that this one felt colder, that means when I touch these two objects, my hands, which are 37 degrees Celsius, is warmer, right? So heat will travel from my hand to the plate, heat will travel from my hand to the bowl. Correct? So the plate feels colder because probably the hand lost more heat or lost heat more quickly. So if it lost more heat quickly, that means heat transferred from my hand to the bowl faster than from the plate. I repeat. So heat transferred from my hand to the plate faster than the amount of heat transferred from my hand to the bowl. So this will therefore show me that the plate is probably a better conductor of heat because it transferred heat from my hand to the plate faster. You want to write something to your answers to see which are the parts that you missed out. So there are certain assumptions that were made. So you have to tell me primarily in terms of heat transfer, it moved from where to where. And since it moved from hand to plate or hand to bowl, the one that feels colder is because better conductor. It transmitted heat from my hand faster or better. So hence is a better conductor of heat. So by definition, we need to state what temperature is. So if you can remember the definition, you'll get this 1 mark very easily. So because this is an easy question, you just need to double check your answer. Make sure you memorize it as a definition. Okay, because this is actually a requirement in your PSLE that you must be able to define what temperature is. And by definition, they actually give it to you. the measurement of how hot or how cold a specific object is. Okay, now let's look at Susie. Susie put the kettle on, heated a beaker of water. Yeah, she was starting to put the kettle on. Then it started to boil. She turned off the heat and recorded the temperature every 5 minutes, and the graph shows the results. So based on the graph, what do you think is the room temperature? Temperature decrease and then remain constant at this point. So very good. Everybody can tell me 20 degrees Celsius. So that is a given based on the graph. So we have to interpret based on information from graphs or tables. So another way that they can give you this information is to give you a table, right? Then at 0 minutes, this is a temperature, 100, for example. Then at 5 minutes, 80 degrees. At 10 minutes, 50 degrees. Then at 30 minutes, 40 minutes, 20 degrees, 20 degrees, 20 degrees. So the lowest temperature that's hit is what I can assume to be the room temperature. Next part, explain why it will be more accurate to record the temperature every minute for the first 5 minutes. The temperature decreased the most quickly. So if this is the greatest and steepest decrease in temperature, it will be more accurate to take more readings so that I can see how the temperature decreased during the first 5 minutes. And it also makes sense that it decreases the most during the first 5 minutes because this is 100 degrees and this is 20 degrees. This is where there's the greatest temperature difference. So therefore, temperature will heat from the water will be lost or not lost, will travel to the cooler air faster because there's a greater temperature difference. Beyond the first 5 minutes, which is down here, now this is the new temperature difference. So the smaller the temperature difference, the slower heat will transfer to the cooler environment. But the bigger the temperature difference, you realize, so based on this graph, I can also make that conclusion that when there's a bigger temperature difference, so this was the starting temperature 100 and this was 20, when the temperature difference was 80 degrees, the heat loss within the first 5 minutes was the greatest. After the first 5 minutes, now this is about 60 degrees Celsius and this is 20 degrees Celsius. So now the temperature difference between the hot water and the room temperature is now smaller. So when the temperature difference is smaller, I realize that the heat loss will also be slower. So these are different conclusions that you must be able to make even based on just one graph alone. Okay? Of course, what I'm saying is a little bit more high level, but it's just in case you need to make more than one conclusion based on the graph. At least you can tell. These are the topics specifically that we'll be looking at: repro in plants and animals, the respiratory and circulatory systems in both plants and animals. We're looking at cells, so different parts of the cells, and that will be the main things that we'll cover in the next lesson.
For question, for question 8, then you said that we could say that the ball was bigger.
Okay, for question 8, you mean this one?
Yeah, but when the ball passed the then there was 0 light detected. So isn't it like already covering the whole space, so it couldn't be bigger, right?
Not really, because okay, if you look at this thing, right? So if my ball was this size, it will still, for a small moment, prevent the light sensor from detecting the light. If my ball was bigger, it will also prevent the light sensor from detecting light. So the ball doesn't need to be the same size as a whole in order for it to block the light source from the light sensor, right? So in this case, if the question was not phrased in such a way, I could potentially say that the ball was a different size, but because here the question specifically gave me a clue at the same speed. So this question is more related to the speed of the ball than the size of the ball, because it is very unlikely that in a question they're going to tackle 2 variables at the same time. Okay? So if they change the question to in the first 20 seconds, they change the question to, let's say, let me type out. Okay, in the first 20 seconds, were all the balls the same size? Then I can say, nope, based on the graph, I can say that the balls are not the same size because the interval for the third ball was longer, for example. But in this particular question, if they're telling me that the clue here is at the same speed, then the question is linked to the speed of the ball, not the size of the ball. Okay, thank you for clarifying. The light sensor doesn't mean it's in the hole, right? Actually, yes, it means that it is passing through the hole because it will not stay in the hole, right? So it's only when the ball position is exactly down here. So by right, there should be an uninterrupted light beam of light that's coming out from the light source that's detected by the light sensor. So as long as there's something that's inside here, it will prevent this direct transmission between the light source and the light sensor. So covering the light sensor means that it's in the hole or passing through the hole. Doesn't mean the size is so big that doesn't mean the size is so big that covers the hole. Doesn't it mean the size is so big that covers the hole? It may not have to cover the hole. The ball can, as long as the ball is smaller than the hole, it can be really, really small, but it can still block the light, even if it's momentarily.